Hello class 10. Today in this video we will discuss about the multiple choice questions of chapter 3, pairs of linear equation in two variables. Now in the first exercise there is no MCQ questions given. So we're going to start with this exercise, that is exercise 3.2. Here the first question is the pair of linear equations x plus y minus 40 is equal to 0 and x minus 2y plus 14 is equal to 0 have a unique solution, infinitely many solutions, exactly two solutions, no solutions. So here we have two equations. So that is x plus y minus 40 is equal to 0, and another equation is x minus 2y plus 14 is equal to 0. Now let us recall that for a system of linear equations, let's see here, a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 is equal to 0. For this system of linear equations, there is a unique solution if a1 by a2 is not equal to b1 by b2. So this, if it is like this, then there is a unique solution. There is a unique solution. If we draw the graph of these two equations, then we will get intersecting lines. Now if a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then there is infinite number of solutions. So there are infinite number of solutions. So when we draw the graph, we will get a coincident line, that is one single straight line for both the equations. Now the third one is there is no solution if a1 by a2 is equal to b1 by b2, but it is not equal to c1 by c2. These conditions implies no solutions, that there is no solution. And if we draw the graph of the equations, then we will get a parallel lines. So here in these two equations, let's check a1 by a2, that is the coefficient of x and here and here, so it is 1 by 1, so 1 by 1 is 1. And now let's see the coefficient of b1 y here. So b1 is plus 1 and b2 is minus 2, so this is minus 1 by 2. Now this one and this one, they are not equal. a1 by a2 is 1, b1 by b2 is minus 1 by 2, which means they are not equal. a1 by a2 is not equal to b1 by b2 here. So therefore the system of equations here, the pair of equations have a unique solution, Now next question, the pair of equation x is equal to 4 and y is equal to 3 graphically represent lines which are, now we have two equations here, x is equal to 4 and y is equal to 3. Now x is equal to 4 and y is equal to 3. Now when you draw the graph of these two equations, what you will get here is, for this first equation you will get like this, x is equal to 4, so 1 2 3 4, so you will get like this. And for the second equation here, y is equal to 3, you will get 1 2 3 here, like this, a straight line. Now this is for x is equal to 4, is 1 2 3 4 here, and this line is for y is equal to 3, 1 2 3 here. Now these two graphs intersect at this point, and this point is here abscissa, that is x coordinate is 1 2 3 4, so x coordinate is 4, and ordinate, that is y coordinate, is 1 2 3, so that is 3 here. So which means that these two graph intersects at the point 4, 3. So here the pair of equations x is equal to 4 and y equal to 3 graphically represent lines which are intersecting at 4, 3, intersecting at 4, 3 here. So option 4 is the right answer. And then next question is, if the pair of equation 8x plus 2y equal to 5k and 4x plus y is equal to 3 represent coincident lines, then k is equal to this, minus 5 by 6, 6 by 5, 5 by 6, minus 6 by 5. Now here we have two equations here. 8x plus 2y is equal to 5k, and another one is 4x plus y is equal to 3. Now we know that for coincident lines the condition is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. a1 is 8 here, a2 is 4, and b1 is 2, and b1 is 1, and c1 is 5k, and c2 is 3. Now here these three quantities are equal. Now this is also 2, so we can consider this. Therefore now if you cross multiply this, then you will get here 5k into 1 is 5k, and 2 into 3 is 6. So you have here k is equal to 6 by 5. So our answer is 6 by 5. The value of k is 6 by 5, which is this second option. So this is the right answer. Now let's see question number 4. The point of intersection of the lines y is equal to 3x and x is equal to 3y is. Now we have two equations here. Y is equal to 3x and x is equal to 3y. Now clearly these two lines passes through the origins, which means they intersect at the origin. Now how do we know that lines passes through origin? Now equation of the form y is equal to ax. Now here this a is a constant, so it can be any number. Now equation of this form always passes through the origin. That is, when you draw the graph, it will always pass through the origin like this. This is origin here. So now this equation is in this form. So these two passes through the origins, which means the two graph will intersect at origin. So we say that here x, since the two graph intersect at the point 0, 0, that is origin, the value of x is 0, y is also equal to 0. Now here in this question, the point of intersection of lines, okay, now these two line passes through the origin, which means they intersect at origin. So here origin is 0, 0. So our answer is 0, 0. Now let's see the next exercise. In the first question we have the value of x satisfying both the equations this and this when y is equal to minus 1 is. Okay, here we have two equations. 4x minus 5 is equal to y, and then 2x minus y is equal to 3, and also the value of y is given here, y is equal to minus 1. Now if we substitute the value of y in any of these equations, then we will get the value of x. So you can substitute this here in the first equation. So 4x minus 5 is equal to y is minus 1. Now we transpose this 5 to the right hand side, so we get here plus 5. Now this is 4x is equal to 4 here. Dividing both sides by 4, you will get here 4 by 4 is 1. So here the answer is, the value of x is 1. So that is the first option is the right answer. Now for the second question, now the next question is, if x is equal to a, y equal to b, is the solution of x minus y is equal to 2 and x plus y is equal to 4, then the values of a and b are. Okay, here we have two equations. X minus y is equal to, and in the question it is given that x is equal to a, and y is equal to b, and then we have to find the value of a and b. So here we just replace x with a and y with b, so we will get here a minus b is equal to 2, and then a plus b is equal to 4. A plus b is equal to 4. Now if we add these two equations, then we will get here plus minus is minus, so 0. Now this is 2a is equal to 6. So here we get a is equal to, dividing both sides by 2, so 6 by 2 is 3. Now the value of a is 3. Now if we substitute this in any of this equation, we can substitute here in the second equation here, a plus b is equal to 4. We can substitute the value of a here, so we will get here 3 plus b is equal to 4, and then here you will get b is equal to 4 minus 3, so which gives us 1. So we got the value of a 3 and b equal to 1, so 3 and 1. So second option is our right answer. Now let's see the next one. If bx plus ay is equal to a square plus b square and ax minus by equal to 0, then the value of x minus y is. Okay, here we have bx plus ay is equal to a square plus b square, and ax minus by equal to 0. Okay, here we have to find the value of x minus y. So what we can do here is, first let's use this one. So here we can take this by to the right hand side, so minus become plus here. Now this one, you divide both sides by a, then you will get here by a. Now we're going to substitute this here. So this one b, so instead of x we will write by a, plus ay is equal to a square plus b square. Now b into b is b square, y by a plus ay, this is equal to a square plus b square. Now what we can do here is, we can take y common, so I'm going to take y common here, so y cut, you will get b square by a square, plus here y cut, you will get here a, oh sorry, there is no square here, b square by a, and then this is equal to a square plus b square. Now let's take LCM. LCM is a here, so you'll get here b square plus here a into a is a square, so this is a square plus b square. That's, so we have here a square plus b square, this a will go up here, and this b square plus a square will go down here. Now this is a square plus b square, now this is b square plus a square, so we can cut this. Now what we got here is y is equal to a. Now so the value of y is a. Now again we will put it here, we'll substitute it here. X is equal to by a, so x is equal to by, y is now a, by a. So a cut, then you get here b. So the value of x is b and the value of y is a. Now the question is asking us x minus y. So x minus y, therefore x minus y is b. X is b minus y is a. So we have here b minus a. So b minus a is the second option. So this 2 is the correct answer. So Roman number 2 is the correct answer, b minus a. Now let's see the next one, that is question number 4. The sum of the digits of a 2-digit number is 9. If 27 is added to it, the digits of the number get reversed. The number is, now we will see this. Now this question, if we try to solve it by making equations here, then that will become a very long process. So instead of doing that, we're going to check with the given option here. So the sum of the digits of a 2-digit number is 9. So here 2 plus 5 is not 9, so this cannot be our answer. This is not our answer. The sum of the 2-digit number is 9. So 2 plus 5 is 7, so this cannot be our answer. 6 plus 3 is 9, so this can be our answer. 3 plus 6 is also 9, so this can be also the answer. 7 plus 2 is also 9, so this can be also the number. So we're going to see which one will be the correct answer. Now let's consider this 63. Now if 27 is added to it, the digits of the number get reversed. It means if we add 27 here, then the number that we should get should be the number obtained by reversing the digits. So the number obtained by reversing these 2 digits will be 36. So if 27 is added to this, then we're supposed to get the bigger number, not the smaller number. So this is rejected. This is not our answer. Now let's see, it's 36. Now 36. Now here, if we reverse the digits, then we will it will become 63. It will become 63. Now what the question says is, if 27 is added to it, if 27 is added to it, that is, if 27 is added to 36, and if we're getting 63, then this must be the right answer. So let's check. Now 36 plus 27 is, this is 3, 1 in hand, 3, 4, 5, 6. Now after adding 27, we're getting 63 here, 7. So this is our right answer. So this is our right answer. Now we will see the next exercise, that is exercise 3.5. Okay, exercise 3.5 here. The first question is the pair of equation x plus y minus 40 and x minus 2y plus 14 is equal to 0 have a unique solution, exactly 2 solutions, infinitely many solutions, no solutions. Here the two equations are x plus y minus 40 equal to 0 and x minus 2y plus 14 equal to 0. So like the questions in the previous exercise, we're going to check the ratio of the coefficients of x and y here and the constant. So we have here a1 by a2 is equal to coefficient of x here is 1 and coefficient of x here is 1. So 1 by 1 is 1. And then b1 by b2, b1 by b2, b1 is 1 here, b2 is minus 2, 1 by minus 2 here, this is minus 1 by 2. Now here we can see that a1 by a2, which is 1, is not equal to b1 by b2, which is minus 1 by 2. So here a1 by a2 is not equal to b1 by b2, which means that the lines are intersecting lines and there is a unique solution. So there is a unique solution. So our answer is the first option, that is unique solution, a unique solution. Now let's see the next one, number 2. Now question number 2 is, if a pair of linear equations in two variables is consistent, then the lines represented by the two equations are intersecting, parallel, always coincident, intersecting, or coincident. Okay, so here we have consistent and inconsistent, consistent and inconsistent. Now two equations are said to be consistent if there is a solution, and two equations are said to be inconsistent if there is no solution, So here for consistent we have unique solution, and the other one is infinitely many solution, infinitely many solutions. So when there is solutions, the two equations are said to be consistent. It may be that they have unique solutions, or there is infinitely many solutions. And when there is no solutions, then we say that the two equations are inconsistent. So for unique solution, we know that when you draw the graph, the graphs are intersecting lines. And for infinitely many solutions, when you draw the graph of the two equations, you will get coincident lines. That is, for both the equation you will get a single straight line. And for no solution, we say that there is no solution if the graphs are parallel lines like this. So when the system of equations are such that the graphs of the two equations are parallel, then we say that there is no solutions, and we say that the system of equations is inconsistent. That is, the two equations are inconsistent. So the answer is parallel. The right answer is Roman number 2, parallel. Now let's see the third one, that is question number 3. Question number 3 here. If the system of equation 2x plus 3y equal to 7, 2ax plus a plus by equal to 28 has infinitely many solutions, then here the two equations are 2x plus 3y equal to 7 and 2ax plus a plus b y is equal to 28. Now for infinitely many solution, we have the ratio of the coefficients of x, y, and the constant are all equal. So a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So this is the condition for coincident line, for having infinitely many solutions. So here now a1 is 2 and a2 is this 2a, and this is equal to b1 is 3 here, and b2 is a plus b here, and c1 is 7 and c2 is 28 here. Now to get the relationship between a and b, to get this one, we will try with this first two. So here these two you can cut here. Now let's cross multiply these two. Now 1 into a plus b is a plus b, and then a into 3 is 3a. Now if you take b to the a to the right hand side, if you transpose a to the right hand side, you get 3a minus 1 here. So now this is 3a minus 1 is 2a. Now let's see whether we have this in the given options. B is equal to 2a, b is equal to 2a. Okay, we have here in the second option, so this is our right answer. Now let's see the next question, that is question number 4. Now question number 4 is, if the lines given by 3x minus 4y plus 7 is equal to 0 and kx plus 3y minus 5 is equal to 0 are parallel, then the value of k is. Now here the condition is given here is the two lines are parallel. Yeah, two lines are parallel, and now we know that for parallel lines, a1 by a2 is equal to b1 by b2, but it is not equal to c1 by c2. So this is the conditions for parallel lines. Now the two equations given here are 4y plus 7 is equal to 0 and kx plus 3y minus 5 is equal to 0. Now here a1 is 3, a2 is k, 3 by k, and b1 is minus 4 and b2 is 3, and this is not equal to c1 by c2. c1 is here 7 and c2 is minus 5, 7 by minus 5. Now we're going to find the value of k, so we will take this 2. So now we will cross multiply. So k into 4 is 4k here, and 3 3s are 9, so we get here 4k is equal to minus 9. Now this is k is equal to minus 9 by 4. Now if we divide this, let's see how much we will get here. 9 you divide by 4 here, 4 2s are 8, 1.0, 4 2s are 8, 2 point is there, so you write here 0, 4 5s are 20, so we get here 2.25. So the right answer is the second option, that is Roman number 2 here. Now question number 5. The pair of linear equation this and this have infinite number of solutions, then the value of k is. Here the pair of the equations given is 3k plus 1 x plus 3y minus 5 is equal to 0 and 2x minus 3y plus 5 is equal to 0. Now these two equations have infinite number of solutions, so infinite number of solutions with this a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Now for infinite number of solutions, this is the condition. Now a1 by a2, a1 is this 3k plus 1 and a2 here is 2 is equal to b1 is 3 here and b2 is minus 3 here. You have to take the minus sign, and this is equal to c1 is minus 5 and by 5 here. So here you get here 1, you get here 1. Now this 3k plus 1 by 2 is equal to, now this is minus 1, this is also minus 1, so you just write here minus 1. Now you cross multiply, 3k plus 1 is equal to 2 into minus 1 is minus 2. So now you have here 3k is equal to minus 2. Now you transpose this minus 1 to the right hand side, so you get here minus 1, plus 1 to the right hand side, so you get here minus 1, and then you get here 3k is equal to minus 3. Now if you divide both sides by 3, so you get here k is equal to minus 3 by 3, which is 1. So the value of k is minus 1. So the right answer is the fourth option.